Hello and welcome back. So this is going to be the last video of this PowerPoint. So we went over a ton of information, a ton of different types of tests, scenarios, data, all of this. And I just kind of like to put a nice little bow on things, just so we can all be on the same page and have a clear idea of what's happening and when to use what. Okay, so the first t-test that we went over was looking at two independent groups. Okay, so in this case, you could be testing like the difference in heights between males and females, the difference in incomes between people with a PhD and a medical degree, for instance, et cetera, right? Two separate groups that are not related. Okay, it's not the same people over some period of time. They are two independent samples. Okay, and what's happening with the independent t-test is it's just saying how similar or how dissimilar are these two samples. Okay, and essentially, theoretically, this is what's happening in the background. We have our sample 1 and our sample 2, and we just want to see how much information overlaps. And if there's not a lot of overlapping information, we are then able to say, based on this little amount of overlap, based on this p-value, that's what that represents, we're able to say that yes, there is a statistically significant difference between the two samples. Therefore, we are then able to say that there is a difference in the population from which these two things came. And then we're able to give a 95% confidence interval for the true difference, okay? The true difference in the population, and that's between two values, okay? Very cool. So visually, this is what's happening. We've got our sample 1, sample 2. We're seeing how much they overlap. If they overlap a lot, we're then able to say, well, there is not a statistically significant difference. And the further these two things grow apart, the bigger that t-value gets. The smaller the p-value gets, the smaller the amount of overlap there is, the more dissimilar they are, or the more unlike they are, leads us to stronger conclusions about the statistical significance. Okay, so that is the first scenario, two independent samples. What if we have samples that occur over a period of time? So it's the same people, like we saw in the pilot study. It's the same pilots pre and post intervention, okay? So you test something, some measure once, and then do some intervention between the pre and the post, and then measure that same thing again after some period of time, okay? And the same thing is happening there too, except it's just a context that is different, right? So however far these two theoretical distributions get of our sample, okay? Again, this is visually what's happening, not really what's happening, but that information is not too important to get hung up on. We have our pre-intervention here, and then we have our post-intervention. And then the amount of information that overlaps tells us how different these two things are. The further these density plots, these kind of smoothed out histograms get, then the stronger conclusions we can make, right? The more certain we are that there is a true difference in populations, okay? And then again, with the 95% confidence interval, we are able to base some inference of the population based on the sample that we got. The bigger the sample, the better, right? Because we're sampling more from the population. We're able to get a better picture of what's actually happening, right? Again, this little shaded area here, this amount of overlap represents that p-value, and that distance between the two peaks, essentially the distance between the two means, is represented as a t-value, okay? Again, focus on the p-value mostly. That's what most people do. Anyway, paired t-test, paired data, same people over some period of time. And lastly, the sort of analog to this is a one sample t-test, okay? And this means that we have to calculate a paired difference column, okay? A new column of data that's just column 1 minus column 2, or column 2 minus column 1, whatever. And then we just test that against some value. In this case, for differences, usually it's 0. I'll give in just a moment an example when it maybe not be 0. And then we compare that to the actual thing that we have, okay? So this blue histogram, density plot, a smoothed out histogram, represents our single column of paired differences. And then essentially what we're doing is we're comparing it to a very similar density plot, smoothed out histogram, but it's centered at 0, okay? And then we just see the amount of overlap there. The closer this sample difference is to this, sorry, that was not English. The closer this sample difference is to the theoretical density plot, then we are able to then say maybe there isn't a difference, right? There is not a difference between these differences and 0. Again, the further these two things grow apart, the more certain we are that there is something happening, right? The intervention is having some kind of effect, okay? Because there's very little information that's overlapped, okay? The sample difference, this red line, totally theoretical. We don't actually have that information, but we kind of create this, at least the computer creates this in the background based on, the same shape that we have here, okay? And that's that. Now, sometimes we may not care if the difference is 0. Okay, we may care if this is some status quo. Okay, so for instance, and this will be it, I promise. For instance, if you said that last semester the average GPA, the mean GPA was, I don't know, 3.4 from Stat 3050, and you wanted to see if this section of Stat 3050 is different than 3.4, what you would do is collect all of the GPAs, find the mean of that class. And then instead of doing a t-test against 0, one sample t-test against 0, you do a one sample t-test against 3.4, okay, 3.4. And now, again, this is something that was done in the past, right? This is already known. This is the status quo. You just want to see if your sample, this section of Stat 3050, is different than last semester's. What does that look like? Oh, well, I'll tell you. All that looks like is you have your one sample. So we'll just do reaction, and it's the difference, right? And within this, there is a mu argument. And it even tells you what it is in the yellow box here, a number indicating the true value of the mean or difference in means if you're performing a two-sample t-test. It's very, very considerate, very, very thorough there with the old definition, right? So by default, when you're doing a one-sample t-test, that mu equals 0. But let's just say you wanted to change it to maybe 100 milliseconds in this case. It's all kind of based on your data that you have here, or the differences, right? So we know that the difference, let me see if I can, yeah, we know that the difference is 195.6. Let's say instead of a difference of 0, we wanted to compare it to a difference of 100 milliseconds. Hit Control Enter there. And the only thing that changes is the t-value and the p-value. 95% confidence interval stays the same. In this case, look, it even says true mean is not equal to 100. And in this case, the true mean is not equal to 100. Okay, because our p-value is really, really large. If we were to kind of shorten this, make that difference 50, we'll see that t-value changes, the p-value changes, and it's kind of going down, right? The closer we get to 0, the closer we get to the truth, the more that's going to be reflected in the p-value, okay? Again, this is just a little extra information. Usually when you're doing a one-sample t-test for differences, it's against 0. And let me just show you. If I run this, we get the same thing, 2.68 and 0.25, right? Very cool. Very cool. There is, I think on your version of the notes, there's some additional information about directionality of t-tests. For now, we're not going to worry about that. I'm kind of more keen on keeping things naive. And that's what most other people are okay with too. As the semester goes on, we'll get more into sort of directionality there. Oh man, t-tests, 3 different types, 2 different scenarios for the most part. Okay, with that, I will see ya in the next one. Gonna miss you.